So in this video we're going to find the inverse Laplace transform of our function here f of s. 2 divided by s to the 4 minus 16. Now the first thing we need to deal with is this denominator. S to the 4 minus 16, that's not going to be a very easy way to directly find an inverse Laplace transform. So we're going to have to try and break this apart. So we've got s to the 4 minus 16. Now we could rewrite that as we got to the power of 4, let's write this one to the power of 4. So we've got s to the 4 minus 2 to the 4, 2 to the power of 4, 16. So now we've got a difference of 2 squares. If we write it as s squared squared minus 2 squared also squared. Obviously 2 squared, we can just change that and put 4 in there. So now we can rewrite our function f of s as 2 over s squared plus 4 times s squared minus 4. So that's equivalent. Now that's a great place to go from. We've got s squared plus 4. Can't really factor that without going into complex numbers. But s squared minus 4, we've got the same thing again here with the difference of 2 squares. So s squared minus 4, we just write that as s plus 2, s minus 2. So now we'll have 3 terms in our denominator. So now we've got 2 over s squared plus 4, and multiply that by s plus 2, s minus 2. Okay, now partial fraction decomposition will definitely work here. So the setup for this would be, for this, 2 over s squared plus 4, s plus 2, s minus 2. That's going to be in some sort of format of a s plus b. So that's a linear term, s squared plus 4, as that's a quadratic. So s squared plus 4. So we can rewrite that in that kind of format. And these here are both going to be s plus 2, s minus 2. So they're just going to need a constant coefficient in the top. So we'll have c over s plus 2 plus d over s minus 2. Now partial fraction decomposition from here is going to be quite time consuming. So I've made a separate video on where we get to on this partial fraction decomposition. So I'm going to show you the result now so we can get on and concentrate on our inverse Laplace transform. If you want to follow the link below, you can see how we got to this result. So here we got d equals 1 over 16. We got c equals minus 1 over 16. And then our a and our b for our term here with the quadratic denominator. We got a was 0 and we got b was minus a quarter. So that's the result of the partial fraction decomposition. So check the link below and you can see how we got to that. That's quite an interesting and quite a lengthy video. Okay, so now let's rewrite that with our partial fraction decomposition result. So now we got minus 1 over 4 times s squared plus 4. So a is 0 and b is minus a quarter. Here we've got c is minus 1 over 16. So we've got minus 1 over 16 times s plus 2. And then we add 1 over 16 for the d. So 1 over 16 times s minus 2. Okay, so that's our f of s. Okay, right, let's take some space, let's make some space on the board and then put this up to the top and let's continue with our inverse Laplace transform. So now dealing directly with our inverse Laplace transform. So what we want now is the inverse Laplace of f to equal our inverse Laplace of all of this. So we've got minus 1 over 4 s squared plus 4 minus 1 over 16 s plus 2 and plus 1 over 16 s minus 2. Okay, now by using linearity, we can break these apart into three separate terms. So let's just do that. So now the inverse Laplace of minus 1 over 4s squared plus 4. Now here we've got a minus sign, so I'm going to put the minus sign in front. So I've got minus the inverse Laplace of 1 over 16s plus 2. And here we've got a positive, so I'll leave a positive sign here. So now the inverse Laplace of 1 over 16s minus 2. Okay, let's just make sure that is kept separately there. Okay, right. Now, this one, and this one, we can deal with these individually. Now, these two here, I've dealt with these in a previous video. And the format these are in is, if I just look at the 1 over s minus 2, 1 over s minus 2. So if I look at that as s minus some constant a, that gave me e to the at. Now here we've got a coefficient of 1 over 16. So here I could just write a c for a coefficient, and that will be our general result for those. This one here is in the same format. And then this one here is of a different format. So this one I've got in the format of c, which would be minus 1 over 4 for our coefficient, and then 1 over s squared plus 4. Now here for our general result we'd have 4 as a squared number, so s squared plus a squared. Now this one here, what I can do is, if I have the square root of a in the top, so if I write that as a, then that will give me a result of a sine function. So that will give me c times the sine of at. So a would be a constant to be found. Well, here we've got a 4. So for this one, I'm going to need to transfer that one a little bit. These ones look pretty straightforward using this general solution. So let's have a look at this one. Now for this one here, I'm not quite in this kind of format, so I'm going to have to do some algebra on that. So let's bring it over and let's just have a look what we can do. So we've got minus a quarter, we've taken that out, and then we've got the inverse Laplace of 1 over s squared plus 4 left. Now s squared plus 4, I want an a squared term here, so my a here will be a 2, so I'll write that as a 2 squared. But I've only got 1 in the top. Ideally, I want 2. So why don't I just write a 2 in there, which now means I've doubled this value. But then after I've done that, if I do, half it from the outside, I've basically got a half times 2, which just gives me 1. So then if I write 2 times 4 in there, I've got the equivalent value for this one. Now moving on to this one, I'm going to use this as a general solution. So now I just need to take the 1 over 16 out. So the 1 over 16 will be with a minus, and then my inverse Laplace of 1 over s plus 2. And likewise with this one, very similar, but with a positive. So now I've got plus 1 over 16, inverse Laplace, 1 over s minus 2. Okay, right. So now we're ready now to solve our Laplace here. So we've got minus 1 over 8. Now this is in the format that we wanted. So we've got c, our constant is minus 1 over 8. Our a, we now have as a 2. So we've got sine of 2t. So we can write that in that kind of format. So let's put our input for our sine function there as 2t. Now this one here, we've got minus 1 over 16 and 1 over s plus 2. Now this was our general solution here. So here our a is minus 2. So we've got e to the minus 2t. So our c would be minus 1 over 16. So minus 1 over 16 e to the minus 2t. So that would take care of that one. Now this one, I've got very similar going on, except for my a would be a positive 2. So now I just need to add 1 over 16 e to the 2t. And that there is my solution for my inverse Laplace transform of this function here. Okay.